A box contains only red chips, white chips, and blue chips. How patriotic. If a chip is randomly selected from the box, what is the probability the chip will be either white or blue? So we want to know the probability that it is white or blue. And of course, the word "or" in probability means that we can add these two probabilities. So this is what we're looking for, the sum of the probability of being white plus the probability of being blue. Statement number 1 tells us that the probability that is blue is 1/5. Well, that's a step in the right direction. We have one of the two pieces, but because we don't know the probability of picking a white piece, this statement by itself is not sufficient. Statement number 2, we have to be very careful here and set statement number 1 aside now. Statement number 2 by itself says that the probability of picking a red piece is 1/3. Well, that's interesting. It's not immediately clear that that's going to be relevant. But you see, if we know that picking a red piece, the probability of picking a red piece is 1/3, then the probability of picking not red would be 1 minus 1/3, which is 2/3. But keep in mind that this idea of not red, well, what happens if you pick a chip and it's not red? Well, not red, that's the same as picking white or blue. There's only red, white, and blue chips. So if you pick a chip and it's not red, it has to be white or blue. And so it turns out that that directly allows us to calculate the probability of being white or blue. So this statement by itself is completely sufficient. 1 is insufficient, 2 is sufficient. Answer choice B.